Hello, my name is Phi. On behalf of the DAGOBAH team, I would like to present our work on semantic table annotation from heuristics to language model. Our annotation system consists of 3 steps. First step, given a relational table, a preprocessing is applied to extract table metadata, such as orientation, header, key column, and using this to determine the annotation targets. Second step, the entity lookup collects candidate entities from the canonical graph for each target table cell. And we use Elasticsearch to index the canonical graph. In last step, we perform 3 annotation tasks: CEA, CTA, and CPA. And in the 2022 version of our system, we print some improvements in the entity lookup, in the entity scoring algorithm, and we propose a novel entity disambiguation by reading entity description. And we care more about the optimization of the performance. Acting as the first step in the annotation pipeline, the entity lookup can significantly impact the overall quality of the system for 2 reasons. First is the richness of alias table. An alias table with low mention coverage per entity has limited lookup capacity. For example, in Wikidata alias table, entity Q55449225 appears under the unique English name in Wikidata, George Strombopoulos tonight, and as a consequence, it's never matched with the mention the hour, but the hour index the correct alias of this entity. Second problem is the ranking mechanism. A good ranking function will have the lookup to hit the correct entity within a small list of candidates. For example, we want to find candidate entities for the mentioned CDG International Airport, and we should expect that the entity CDG Airport should be ranked higher than entity International Airport because CDG is more informative than international. We propose solutions for the 2 problems of entity lookup mentioned in previous slide. First, we can enrich the current alias table of canonical graph by supplementing it with external alias source. For example, in our work, we can use 4 external sources, including Wikipedia, Wikilink, to enrich alias table of Wikidata. And the table on the right shows some statistics on the contribution of each alias source to the augmentation of Wikidata alias. In the last slide, it shows us we are able to add from 1 to 3 new alias in average per entity and per source, and this largely improves the coverage of the lookup. Second, in ranking function, we incorporate 3 ranking factors into the final ranking score, such as Fuji score based on Levenstein distance, PM25 score like TF-EDF score, and Byron score. We evaluate the hit rate of the old and the new lookup at different number of return candidates. And we do this on 3 datasets: IMAI, T2D, and touch table. And clearly, the lookup with alias enrichment and complex ranking function outperform the other by higher hit rate, and it approaches the upper bound on the capacity much faster. And looking at the blur curve, within only K equal to 10 candidates, the performance is already competitive with other larger Ks. Next, we now discuss the core of our annotation system, the entity scoring algorithm. Specifically, we want to give a score to a candidate entity of a mention in the table. For example, considering the table below and a mention in its Lagunia in New York, USA. This nation has a candidate Q319654 LaGuardia Airport, and we want to evaluate the relevance of this entity. We use two score components. First component is the context score of the entity given the table context. For example, here, if we have the table context is airplane 1,000 feet, like from airport business. And this score is calculated by DAGOBAH SN 2021, which is our last year system. The second component is the prior knowledge of the entity, even solely mentioned is referred to. It is resulted from the entity lookup. And finally, we have an activation function applied on the prior score. We want to stress that the choice of activation function F is important. Our intuition is that a good activation function should distinguish well the high score and the low score. For example, entity of prior score higher than 0.9 are more likely good candidates, and entity of prior score lower than 0.7 are more likely bad candidates. And we want these two paths are far away, should be far away. And we test two functional family of F, and it shows us the sigmoidant function achieve better performance than exponential function. In this slide, we propose a novel entity disambiguation based on column header and entity description. In fact, table headers, if appropriately given, can help to disambiguate the entity. And we can see it from the table here. Given the header of the second column is airport name, you can easily conclude that the correct entity for the mentioned LaGuardia New York US Airway is LaGuardia Airport and not a town or an airline company. So, how to know if LaGuardia Airport is relevant with respect to header, aircraft type, airport name, altitude pin? One solution is to read the description and try to understand it. Example, LaGuardia Airport is a civil airport in East Amos, Queens, in New York City. And we formulate the problem as a binary text classification task, where we take as input the header and the entity description, and we output a value between 0 and 1, indicating the relevance of the entity with respect to the header. For modeling F, we fine-tune an Electra-based cross-encoder on Wikipedia table. And some examples are shown here. LaGuardia Airport match very well with the header, airport type, airport name, altitude pin. And whereas other entities are not relevant. We report the performance of our annotation system in 3 rounds of SemTab. We want to highlight two things. First, the CEA and CPA's tasks on SemTab table are successfully solved, except for purely table data, where we found that entity disambiguation using header is very useful for these datasets. With a rough comparison with the last year performance of DAGOBAH SM, we did get considerable improvement. And second, we observed that our CTA score are sometimes good, are sometimes bad. And during our experiments, we usually question the gold standard provided for CTA, and we believe that an adjudication phase is needed for this task. And that's all we want to talk about our annotation system. For conclusion, this year, we have made some improvement in the entity lookup and scoring. we propose a novel entity integration by reading entity description, and we optimize our system with about 30% gain in processing time. And DAGOBAH is available via an API, and people can create a free account and request access for research purpose. And for future works, we will dive more into the use of language model and canonical graph to improve the annotation quality as well as to deal with table complexity. And as shown in our 2022 system, at the first step, we use a burst-based cross-encoder to better understand the header of a table. And the next step would be focused on graph embedding and table modeling using language model. Last but not least, we are using enterprise canonical graph to annotate business-related data instead of wiki data. That's the end of our presentation. Thanks for listening.